Hi everybody. Okay, we are starting a new little unit and it's on laws of exponents. This is something that you would have learned in Algebra 1, but lots of things are learned and forgotten. So we're going to go back over all the rules. So I have a song for us today that I want to sing, and it's to the tune of If You're Happy and You Know It. If you're happy and you know it, clap your hands. That song? Okay, so I'm going to sing it for you a few different times, and then I'm going to show you what each line means mathematically. Okay, so here it goes. When you multiply same bases, add exponents. When you divide, you have to subtract. If there's a power to a power, then you multiply that, and anything to the 0 power is 1. Okay, I'm going to sing it again. When you multiply same bases, add exponents. When you divide, you have to subtract. If there's a power to a power, then you multiply that, and anything to the 0 power is 1. Do you like it? Is it catchy? Do you think you'd hear it on the radio? Probably not. Okay, I'm going to sing it again. When you multiply same bases, add exponents. When you divide, you have to subtract. If there's a power to a power, then you multiply that, and anything to the 0 power is 1. Are you getting the hang of it? You want to sing it with me? I'll slow it down a little bit. You can practice singing it with me. Let's try. When you multiply same bases, add exponents. When you divide, you have to subtract. If there's a power to a power, then you multiply that, and anything to the 0 power is 1. All right, so now let me show you what everything means mathematically. So when you multiply same bases, I want to show you what that looks like. This is what it looks like when you multiply the same base. So what I mean by base is, the base is what's ever under the exponent. So if whatever's under the exponent is the same, that's called the same base. So if these are both x's, that's the same base. If these are both y's, that's the same base. If these were both 2's, that'd be the same base. So when you're multiplying the same base, the rule is you're going to keep the base and you're going to add the exponents. So 8 plus 3 makes 11, and that would be my answer. So this is what it looks like when you multiply the same base. Now, I want you to understand what this means visually. So what this means is I have 8 x's, so I drew 8 x's for you, and I'm multiplying it with 3 more x's. So I want to know how many x's that is at the end. So it'd be your 8 x's plus your other 3 x's, which is 11 total. So on all of these exponent problems, we could draw out a visual representation if we wanted, but sometimes it's a real pain to draw out all the x's that the problem gives you, so that's why there's rules, okay? And so first rule is when you multiply same bases, add exponents. So I added 8 plus 3. All right, let's look at an example for when you divide. When you divide, you have to subtract. All right, so this is what it looks like when you're dividing the same base. So in order for the rule to apply, these do have to be the same base. Both x's, both y's, both z's, both 2's, both t's. So as long as you're dividing the same base, the rule is you keep your base and you subtract your exponents. So 8 minus 3 is 5. And I want to show you a visual representation of this. So what this problem means is I have 8 x's on top, I have 3 x's on bottom, and if I was to cancel out x's, this top x could cancel with that bottom one, shoop. This top x could cancel with that bottom one, shoop. That top x could cancel with that bottom one, shoop. And I'd have 1, 2, 3, 4, 5 x's left. So like I said, I could always draw a visual representation to do these problems, but sometimes the rule is faster. So this rule is when you divide, you have to subtract. So 8 minus 3 is 5. Okay, our third rule If there's a power to a power, then you multiply that. So anytime I have a power raised to another power, an exponent raised to another exponent, I multiply the exponents. So I keep the base and I multiply my exponents. 8 times 3 is 24. And that's my answer. Now I wanted to show you a visual representation of this. This means I have 3 sets of 8x's. So I drew 3 sets of 8x's. So if I want to know how many I have total, I'd count them. 1, 2, 3, 4, 5, 6, 7, 8. Another 8 to it would make 16. So 8 plus 8 is 16. And add another 8 and I'd get 24. But what a pain to draw out 3 sets of 8x's and then have to count all the x's. So that's why we have a rule. If there's a power to a power, then you multiply that. So 8 times 3 is 24. And then the last one, and anything to the 0 power is 1. So if I have anything raised to the 0 power, and all of this stuff is getting raised to the 0 power, everything in the parentheses is getting raised to that 0 power. But I know that anything to the 0 power is 1. So my answer is just a 1. Now, this rule is a little harder to explain. So I'm going to show you 2 examples of why it works, how it works, and you could do this for every number out there. Okay, so first I want to show you 2's, and the goal is to see a pattern here. All right, so 2 to the first power is just 2. 2 squared, 2 times 2 is 4. 2 cubed, 2 times 2 times 2 is 8. 2 to the fourth, 2 times 2 times 2 times 2, that's 16. Okay, so if I was to see what's happening as I go backwards, to get from 16 to 8 and from 8 to 4 and from 4 to 2, things are dividing by 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. Well, what's 2 divided by 2? 1. So this is showing you that something raised to the 0 power is 1. Okay, I'm going to do it again, but this time I'm going to do it with 3's. So 3 to the first power is 3. 3 to the second power, 3 times 3 is 9. 3 to the third power, 3 times 3 times 3, that's 27. And 3 to the fourth power, 3 times 3 times 3 times 3, that's 81. So if I was to try to figure out what's going on, if I go backwards to get from 81 to 27, from 27 to 9, from 9 to 3, do you know what's happening? These are dividing by 3. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And what's 3 divided by 3? 1. So this is showing you that something raised to the 0 power is 1. And I could do this with every number out there, and this is what's going to happen every time. Anything to the 0 power is 1. So anytime you have stuff raised to the 0 power, the answer is going to be just a 1. Okay, so this is a review of 4 of our major rules. There is one other thing that you will learn starting tomorrow, and it's about negative exponents. But for today, these are the 4 major rules I want you to know. So I'm going to sing the song to you again. When you multiply same bases, add exponents. When you divide, you have to subtract. If there's a power to a power, then you multiply that. And anything to the 0 power is 1. Okay, what your assignment is for me today is you're going to sing this song to me and send it to me through Canvas. I don't need to see your faces. If you want to show me your beautiful faces, I'd be happy to look at them. But you don't have to show me your face. I'm clearly not showing you my face right now. So it doesn't matter. Show me your face. Don't show me your face. But I need you to make a recording of yourself singing this song and then you're going to go to where it says Canvas Post on the calendar, and you're going to post your singing of this song. Okay? So I'll sing it one more time, and then you'll sing to me. When you multiply same bases, add exponents. When you divide, you have to subtract. If there's a power to a power, then you multiply that, and anything to the 0 power is 1. Okay, so make your song for me and upload it to Canvas. I can't wait to hear your beautiful voices. Smiley face.